In this video, I'm going to show how to derive the volume form in spherical coordinates, which we stated was rho squared sine phi d rho d phi d theta. So this is a pretty involved calculation. So first let's recall the definition of spherical coordinates. So Cartesian coordinates in terms of spherical are x equals rho cos theta sine phi, y equals rho sine theta sine phi, and z equals rho cos phi. So as we did in the previous video, we can calculate the product of these three d's. We can calculate the product of these by putting them into a determinant, and that will account for the funny sign rules when we multiply them. So dx, dy, dz will be the columns of in this determinant. Okay, so dx will be, let's see, cos theta sine phi d rho, then negative rho sine theta sine phi d. Oh, actually, I should do this in the order with phi first. So rho cos theta cos phi d phi. And then the last coordinate will be negative rho sine theta sine phi d theta. And I'm already going to run out of space. So what I'm going to do is rewrite this a little bit. So sort of mixing coordinates. So this I can write as x over rho. And then this guy, this is negative y. And this is a little bit harder to rewrite, but we can, I guess we can take x times z. So that will now have like a rho squared that we don't want, and it'll have a sine phi that we don't want. So this is xz mod, or sorry, divided by rho sine phi. So if we rewrite this more compactly, it'll be, this will be x over rho d rho, xz over rho sine phi d phi, and negative y d theta. Then we'll do the next thing for dy. So dy will be sine theta sine phi d rho, and then rho cos phi sine theta d phi, and rho cos theta sine phi d theta. Now again, we can rewrite this. This is y over rho d rho. The next one is yz over rho sine phi d phi, and the last one is x d theta. Then let's see, and then dz is going to be cos phi d rho, negative rho sine phi d phi, and 0 in the theta component. Okay, so now let's try to evaluate this big determinant. So first it'll be this big determinant. If we erase the d's, we can take these out and it'll be this times d rho d phi d theta. So get rid of those. Okay, so now, and we can also rewrite the last cos phi is z over rho. Okay, so we'll use some properties of determinants. Now we can pull out a constant from one row. In this case, the constant will be 1 over rho. Two different rows I'm talking about. So this will be 1 over rho determinant of x, y, z, negative y, meant to delete this d theta as well, x 0. And for the middle, we'll also pull out a factor of rho 1 over rho sine theta in the second row. So this will be 1 over rho squared sine phi, meant to say phi, xz, yz, and now here we'll have negative rho squared sine squared phi. Sorry. Negative rho squared sine squared phi. So we want to take the determinant of that. Now this is almost all in xyz coordinates. But remember, since x is rho cos phi sine phi and y is rho sine theta sine phi, we have that rho squared sine squared phi is equal to x squared plus y squared. So this is sort of the key thing we need to simplify this. So now we can evaluate this determinant. Let's evaluate it by expansion along this column. So this is equal to z determinant xz, yz, negative y, x, plus rho squared sine squared phi of x, y, negative y, x. Okay, so that, and then we'll divide all of that still by this. So this gives us z squared x squared plus y squared, and this guy is x squared plus y squared, and this is x squared plus y squared. So this becomes x squared plus y squared times x squared plus y squared plus z squared. But then this is rho squared. So what this becomes x squared plus y squared. So that's rho squared sine squared phi. That's this. Get rid of this. then times another rho squared. So that's rho to the fourth. And then we're dividing by rho squared sine phi. And so this cancels out. This becomes a 2. And then again, that was times dr or d rho d phi d theta. So yeah, our final answer is rho squared sine phi d rho d phi d theta. Now, let me show a slightly easier way to get to that using cylindrical coordinates. So that was pretty long. So remember, in cylindrical coordinates, our volume differential is r dz dr d theta. So the conversion is r equals rho sine phi. This is sort of what we were just saying a moment ago. The thetas are the same, and z is rho cos phi. Okay, so first let's calculate this. So for that, we'll take rho cos phi. This is, right, so I want dz dr d theta. And as before, we can sort of just pull out the d. So the dz is cos phi. And again, I'll put the d rho d phi d theta here. So cos phi is with respect to rho. With respect to phi, it's negative rho sine phi. And then with respect to theta, it's 0. dr will be sine phi d rho. With respect to phi is rho cos phi, and with respect to theta is 0. And then theta, since the thetas are the same, we'll put a 0, 0, 1 here. So this determinant is a lot easier to evaluate. So this will be rho times cos squared phi plus sine squared phi is just rho. So, or rho d rho d phi d theta. So our volume form is r times this, so is r times rho d phi d theta. And then since r is rho sine theta, that becomes rho squared sine phi. And again, anytime I say theta out loud, there's a good chance that I meant to say phi.